All right, so in this video, I will be going over question 15 that we did in class again. So let's just pop this open to full screen. So again, question 15 is, how much heat do you need to warm 10 grams of ice at -10 to steam at 110? Bunch of constants. So I'm gonna actually go on to a new sheet to do this problem and referring back to this sheet of constants. So the first thing we always want to do when we're doing like a heating curve problem is we want to actually draw the heating curve with my tablet, right? So I don't draw crooked. There we go. So it is temperature on the Y and heat added on the X. So we start at -10. And we're going to raise our temperature until we hit, in this case, it's going to be the fusion point because we start as a solid. The fusion point of water is 0. Once we hit that fusion point, all of the energy goes into transforming solid to liquid. So temperature doesn't actually change, so it's still at 0. Once we're all a liquid, though, we can start raising our temperature again. And so we're going to raise our temperature till we get the boiling point. At the boiling point, the same thing's going to happen. We are not going to change temperature until we are all gas. So we're going liquid to gas here. And then we raise to our final temperature, which is 110. So we're a gas. And we only have two equations. Q equals N times delta H. And Q equals mass CS delta T. Now, the top equation, let's look at it. Q is heat. N is moles. Delta H is enthalpy. So remember, enthalpy just is how much energy to do a process for 1 mole of substance. So how much energy, and this is in kilojoules, to perform a reaction. And in this case, our reactions are phase changes for 1 mole of substance. The bottom equation, Q is still heat, mass is mass, CS is specific heat capacity. So that's heat capacity. What heat capacity is how much energy do I need to raise 1 gram of a substance by 1 degree Celsius. Delta T, change in temperature. It's always going to be final temp minus initial temp. Okay, so if we look at our heating curve, we have 5 different things we have to calculate. We have to calculate going from -10 to 0 as ice. We got to calculate how much energy it does to melt or do fusion. We have to calculate how much energy it takes to heat up our liquid. We have to calculate how much energy it does for vaporization. And then we have to calculate how much energy it takes to heat up our gas. So for parts 2 and 4, we're going to be using our phase change equation. Parts 1, 3, and 5, we're going to be using our delta T equation. So I'm just going to calculate each part one by one. So segment 1, Q equals mass. So go back to the previous problem. The mass is 10 grams. Multiply by the heat capacity of ice, 2.09 joules grams Celsius, multiplied by delta T. Our final temperature for ice is 0 minus our initial temperature, which was -10. We do this calculation and we get 209 joules or 0.209 kilojoules. So that's our first segment. And then we're going to just do the similar things for all these different segments and add them up at the end. So our second segment, segment 2, is we're taking this ice and we're melting it. So Q equals moles. Well, I have a weight. I don't have moles yet, so I need to calculate that. My moles are 10 grams divided by 18.02 grams for every 1 mole. And I believe that's 0.55, but I'm going to take out my calculator and make sure I have that right before I write it down. 10 divided by 18.02. Yep. 0.555 moles. So Q equals 0.555 moles multiplied by delta H. So we're doing a fusion process, so I need the delta H of fusion, which is 6.02 kilojoules per mole. So do that calculation. And the amount of energy it takes to melt this ice is 3.34 kilojoules. Okay, once we melted that ice, we can now heat up our liquid. So we have 10 grams of liquid. The heat capacity of water is 4.184 joules gram Celsius. Multiplied by our final temperature is 100, our initial temperature is 0. So this is 4,184 joules or 4.184 kilojoules. Right now, segment 4, we are going to take our liquid and change it into a gas. Now we're doing vaporization. So we're using our phase change equation. Q equals moles is still 0.555 times the delta H of vaporization, which here is 40.7 kilojoules per mole. So it is 22.6 kilojoules. So we have changed all our liquid to gas. Now we have gas at 100 degrees, so we have to heat it up to 110. So we're going to use our mass equation. Q equals weight is 10 times the specific heat capacity of vapor, 2.01 joules gram Celsius, and this was also grams, multiplied by our final temperature is 110. Our initial is 100. That would be 201 joules or 0.201 kilojoules. All right, so what we did is that we broke our heating curve into segments, calculated the energy for each step. Now all I'm going to do is I'm going to start to add up all of our energies to find out how much does the entire process take. 0.201. And when I do that, I have an energy of 30.534 kilojoules. So to take this ice and turn it into steam, you have to put that much energy in, all right? So again, once you have the heating curve and you remember how to use our 2 equations, just follow that heating curve for each of these parts to help you figure this out. All right, so that's our heating curve problem. And the next video, I'm going to do question 16, which is our cooling curve problem. So I will see you in that video.